Hello, everybody. I'm Jeff McChesney. I'm a CEO and founder of a company called Target Arm, and we have a device that I'm going to show you today, which enables the launch recovery of both rotary and fixed-wing drones from any moving vehicle. We can do that autonomously, and we can do it at high speeds already at over 65 miles per hour. So let me show you why we want to be doing this. Next slide. Okay. If you could go to the movie, please. People across the world are in transit more and more every year. In addition, digital networks now connect people in all modes of transportation. But why can't our physical world connect to us as well? With the massive proliferation of autonomous drones, why can't we have things delivered to us while we're going somewhere? Those are good questions. I'm Jeff McChesney, CEO and founder of Target Arm, and I can answer them. We can. For aerial drones, the big problem is about the last inches of delivery. It's really difficult to land on something moving until now. This is Tular. Our simple but elegant device launches and recovers both rotary and fixed-wing drones autonomously from any moving vehicle, train, bus, ship, or even an airplane. Imagine the possibilities, from package delivery to oil and gas, to first responders, to the military, and even to airplanes. Here you can see a fully automatic Tular recovering a drone and how the pin array actually works. And here you can see a fully autonomous drone and fully automatic Tular working in perfect unison for a hands-free recovery. Also, please note how Tular automatically launches a fully autonomous drone and how its station keeps with Tular prior to exiting on a mission. Okay, thank you. Back to slides, please. Okay, so the key component to this is it's both rotary and fixed-wing drones, and I'll tell a little bit more about that as we go forward. Next slide, please. We're dual use capable, both commercial and military. As you saw in the presentation, we've got the package delivery solution. That's our first solution. We're at MVP on our package delivery solution, although the airspace in the United States is not yet open up. And then we've got the military aspects associated with it, both on the ground and in the air. And we've got initial target markets of oil rigs and wind farms, both in the lower corners, where we've got already traction outside the 12-mile limit outside the United States. Next slide, please. Our total addressable market just in the United States is $22 billion that we've modeled on two specific industries, the military being at $5 billion TAM with 200,000 combat vehicles, and for the package delivery market, a $17 billion TAM with 600,000 and growing delivery vehicles with a direct sales model here in the United States. Next slide, please. There's no other competing technology which comes even close to what we're doing. We own the upper right quadrant by ourselves. Taking a look at the two axes, you look at being able to operate at speed, and we're already at over 65 miles per hour and going higher, and being drone agnostic and being able to not just use rotary wing vertical landing, but also horizontal landing, both with rotary and fixed wing. And virtually all the money is being spent down in the bottom left-hand quadrant for rotary wing and vertical landing only, and not being able to handle the in-transit operations, which basically half the world's doing. We've done strategic agreements that are listed here that start opening up the drone capabilities in the market for us so that we can accelerate in faster. Next slide, please. We've got deep industry experience on our staff, me included, aeronautical engineer, mechanical engineering, electrical engineering, with computer science and deep sales and startup experience. I'm a former combat pilot flying F-15s for the United States Air Force. Next slide, please. Our timing is perfectly aligned with the marketplace. What we've decided to do is, and we're executing on it, is going after military contracts because of the airspace restrictions are not applicable. Then as the airspace starts opening up here in the United States, as well as other nations across the globe, heading into the oil and gas, which has a very demanding need for inspection capability, and then eventually into the package delivery market, we're hoping by the end of this year and early next year. And our production schedule and technology schedule follows that as well. We're fully patented here in the United States for our technology as well. Next slide, please. You gained significant traction. We've had 5 DoD, Department of Defense, Small Business Innovation Research, and Small Technology Transfer Research contracts. We're currently completed 4 of those. We're currently executing a phase 2 for the fixed wing capability for the nuclear munitions convoy protection for the United States Air Force. We've also had a contract with BAE Systems for R&D contract working for the Army to put it on the Stryker armored personnel carrier. Next slide, please. What we're looking at right now is a C2 investment, which I'm currently in. If you take a look at my revenue growth that we're looking at right now, it accelerates quite rapidly. This is a model that we built upon that is quite oriented around a SaaS model. I've got previous startup experience working with SaaS companies as well, and I've designed our gross margin, our EBITDA, along the same way. We've already got significant cash built up with generating revenue. With 13 months of cash, and we got 14 months of backlog as of today. Next slide, please.
30-second warning.
And that's it. I'm Jeff McChesney, and we're in the middle of a $2 million raise, and thanks for the warning.
Hey, Jeff, I have a question. So
sure.
I actually run a joint venture with one of the companies listed on your slide deck.
Awesome.
Focused on last mile package delivery, small UAS, all that good stuff. So I'm curious, who in the commercial space, what do you see your path to market, right? Because you have to, is it the drone manufacturer? Is it the vehicle manufacturer? Because I'm living and breathing type certifying a small UAS right now.
Yep.
And it's all about the ConOps. And so I'm curious how do you see your path to that market? Because you kind of have to work with both, right?
Yeah, absolutely. We have to work with both. So I will tell you right now, we've been approached by two, I can't name them, OEMs for vehicles. These are car manufacturers and truck manufacturers. So they're already talking about, and I mean, Ford put a press release out a couple of years ago that they wanted to put them on Ford F-150s. 3 oil and gas companies have approached us independently in the West Texas Permian Basin to put our capability on a Ford F-150. So actually, they're naming the actual vehicle that they want it on. I can't name the companies that we're dealing with. So what's happening right now is the manufacturers of ground vehicles and military vehicles. They're going to be partners of ours, right? They're going to say, okay, how do we integrate with Tular? How do we bolt it on? How do we embed it? What do we do with it? Same thing goes with drone manufacturers, because we're not a drone company and we're not a car manufacturing company either. We're the enabling device that sits between those two. And so with drone manufacturers, what we have is a certification model. Think of Intel inside. You're going to have Tular capable drone manufacturers. We're currently certifying the first drone company, which is Greenside Ag out of Boston. We met them at the TechStars Accelerator of the Air Force Accelerator we were in as well. So, excuse me, they're currently certifying right now the first drone, and then the other ones will come in over time as well. So we'll open it up and we'll work with them. We'll certify them, and then they'll be able to go to market with the capability, and then the business models can lay on top of that of the solutions.
One more quick question. Do you have an idea, do you have a feel for how long it takes the U.S. to allow you to take off and land on a moving platform? Because their regulations are super restrictive right now to very defined routes and risk mitigation techniques.
Yeah, I mean, the issue with the airspace in the United States for package delivery is it's not open, right? I mean, it's a restricted airspace. It's a limited use capabilities today, but it's coming. The drumbeat is too great. It's pounding right now, where people are wanting to be connected in transit, and you're going to want to get faster delivery in your supply chains. And so you don't want to disconnect from your shipping as it's waiting to come into port, from your trains to your buses to people in cars to military vehicles to even to airplanes. Our current contract right now that we're under with an STTR with MIT is for the Air Force to put it onto a cargo airplane. So we're moving in multiple directions simultaneously, but it's going to take time for the public to accept it and the processes and procedures to be defined.
Okay, thanks, Jeff.
Yeah, you're welcome. Thank you, Jeff.
Anyone last question for Jeffrey McChesney?
Yeah, I have a question.
Sure.
Miller Ogun, Snowball Capital. Jeff, how does this differ from Workhorse's Horsefly? Because I believe it's very similar, especially for in-transit delivery, but they don't have the capture. It syncs with the vehicle. Yep. And it lands without a capture.
Yeah, so I've spent a lot of time talking to the advanced development group at UPS, and in particular for this Horsefly solution. They are a stationary solution. So on my competitive chart, they're in the bottom left corner too. So what they've got for a ConOps design is that they would end up stopping, launching a drone, possibly driving someplace else, stopping, waiting for the drone to come back, waiting for it to land, then get moving again. We don't have to stop at all. You don't even have to get out of the vehicle. And one of the key components, Taylor, that I want everybody to understand in the package delivery market is when you have a driver stopping 150 times a day and getting out and getting back in, that's one efficiency model, right? Now take it where they don't have to get out at all and they can deliver. That's a decrease of, an increase of 3 times the productivity. Now they're only working 1/3 of the day. Take the driver off of there and being able to work autonomous. Now you get a 9 times in productivity improvement out of that vehicle. That's where we're heading with package delivery.
So if the technology catches
on
up,
Taylor's question, only because he named some stuff that I'm near and dear to my heart. I understand you can take off and land from the moving vehicle, right? But how do you reload the next package? Because the driver has to do that.
Yeah, so we're developing right now the handoff mechanism that works inside Tular, inside of a vehicle or inside of a cargo airplane. So inside of an autonomous vehicle, we're designing the handoff capability to put the drone in and back out. And then the next phase that we're going to design is the conveyor system and the stowage system and the reloading of packages or payloads or fuel or whatever you need to be doing as well. So there's a series of Tular works. It's MVP. We're working on the feeder mechanism next, and then we'll work on the actual internal system for conveyance and assembly after that. I'm sorry, Taylor, I think you may have a question as well.
yeah, just if the technology catches up where drones can land on moving objects without, they're just synchronous, what happens to your product? Is there some advantage that you have that, let's say DJI has some kind of transmitter in every vehicle that it can perfectly fly along with it and land?
Yeah, so aerodynamically, this is the problem for most people is that you can get two things to be together, and you can actually vertically land on it at coast speed. As soon as it touches, it blows right back off. So the issue is once you get above 15 miles per hour or so, it depends on how it's actually done. If you don't actually grab it and hold it, that thing is gone. Especially when you get up to speeds at highway speeds that we're operating at 65 and heading to 150 to 200 knots on board airplanes. You've got to be able to constrain it easily and efficiently and reliably at high cycle rates, which is what we've designed to do. So could you actually touch down on top of a vehicle at high speed? Yes, but you're gone. Just put something on top of your car and start driving away and see what happens. It's the exact same concept.